Okay, so today we're going to be talking about the distributive property. Our content objective is students will be able to simplify expressions using the distributive property with rational coefficients. Our language objective is students will be able to state distributive problems correctly, so we will be practicing reading them aloud. Why am I learning this? Well, it's important for solving multi-step equations. So, some quick background knowledge. We should recall from 7th grade the commutative property, which allows us to mix the order of numbers. This works for addition and multiplication. So notice here we have equivalent expressions. 5 plus 7 is the same as 7 plus 5. They may look different, but they represent the same value. Same thing with multiplication. Now with the associative property, it was all about regrouping. We can regroup and it's going to be okay. And this again only works for addition and for multiplication. Hopefully you recall this from 7th grade. And again, we have equivalent expressions. For example, this is equivalent to this. It means the same thing. Okay, so now let's talk about the identity properties. For addition, 0 is our additive identity because anything plus 0 is the same, but for multiplication, 1 is our multiplicative identity because anything times 1 doesn't change its value. So for example here, if I multiply by 5/5, it's going to equal 10/15, but guess what? 10/15 is still going to reduce to 2/3. And why does this work? Because 5 over 5 is technically just 1. Anything times 1 doesn't change its value. So again, these two fractions are equivalent, except they look different, okay? But they represent the same thing. Now, last but not least, let's talk about some inverse properties. For inverse property of addition, we have opposite numbers. We have a positive and we have a negative. These are called additive inverses. But for multiplication, we're going to have the reciprocal of the number. So the reciprocal of A is 1 over A. So here's some more examples. 3 1/3, 7/9 and 9/7. These are our multiplicative inverses. So these properties are definitely going to be used for when solving equations. In fact, we will be using these properties pretty soon. And last but not least, let's talk about distributive property. You should have learned about distributive property since 6th grade. Here, A times the quantity B plus C. So notice how I read this problem. I said A times the quantity of B plus C means A times B plus A times C, and A times the quantity B minus C is the same thing, except it's A times B minus A times C. So here we can solve it two ways. We can use the order of operations, or we can use distributive property. But notice we're still going to get 27. So some of you might be wondering, why in the world are we going to use distributive property? Well, because what if you have an algebraic expression? Are you going to be able to simplify x plus 2? I don't think so. So let's take a look. What does this actually mean? Well, this means there's 3 groups of x plus 2, so let me write that out. This is basically repeated addition. That's what multiplication is. Now I'm going to use the commutative property of addition to kind of rearrange the x's together and the 2's together. That's the commutative property of addition. And when I simplify it, I'm going to get 3x plus 6. So why do we use the distributive property and how do we use it? Well, let's see. Well, first, again, the reason why we would use it is because sometimes you can't simplify it because you have variables involved, and this is as simplified as you can get. So how do we use distributive property? Well, you distribute 3 to each and every term. So 3 times x, and then 3 times positive 2, which is going to give you 3x plus 6. So let's look at some examples from 7th grade. Here we're distributing 5 to a positive term and to another positive term. And you're going to get 5x plus 15. Here you're distributing a positive term to a positive, then to a negative term. So you're going to end up with 3m minus 24. Okay. So real quick, let's read these problems correctly. You would say 5 times the quantity x plus 3. Here you would read it as 3 times the quantity m minus 8. And another thing I just want to mention real quick is this expression is equivalent to this, and this expression is equivalent to this. These two are just the simplified versions of the original problem. First, let's go ahead and read this problem out loud. I would read this as 3 times the quantity of x minus 2 3/10. So now what you will do is you're going to go ahead and distribute. I'm going to distribute 3 to the x, so that's 3 times x. And now here, be careful, you're distributing a positive times a negative number. So I'm going to go ahead and say positive times negative is a negative. I'm going to go ahead and put that subtraction right away and multiply 3 times 2 and 3/10. Now I'm just going to go ahead and simplify. 3 times x is 3x, and that a negative 3 times a positive 2 and 3/10 is going to be negative 6 and 9/10. So notice I am using the order of operations and doing multiplication before I do any subtraction. Now, something that I want to focus on is I want you to understand yet again that this expression here is equivalent to my original problem. This is simply a simplified version of the first expression. Okay? So now I'm going to go ahead and have you take a look at the next problem. If you want, you can go ahead and pause the video and try it on your own. Go ahead and show you the steps on how we would do this problem. So here you would distribute a 5/10 times 8x. So let's write that down. 5/10 times 8x. And then here you're going to go ahead and distribute a positive times a positive. So that was going to be plus. 5/10 times 6. I'm going to write that down. And notice I keep changing it to this dot instead of an x, because if I showed the multiplication sign using this, it might look like the variable x instead of multiplication. So now I'm going to go ahead and simplify what I have. 5/10 times 8 is 4x, and a positive 5/10 times 6 is a positive 3. Another way you can read this is what is half of 8x? What is half of 6? Because 5/10 is half. So I'm going to go ahead and say that I concluded that the expression is 4x plus 3. But again, notice that these two expressions are equivalent. I can't say it enough. They are equivalent. So make sure you understand that. So now, moving on to number 3. If you want to, you could go ahead, again, pause the video and try it on your own. Otherwise, I'm just going to go ahead and move on. So first things first, we're going to distribute negative 1 and 2/10 to 6x. I'm going to write it like so. 1 and 2/10 times 6x. Now I'm going to go ahead and distribute a negative 1 and 2/10 times a negative 1 and 4/10. A negative times a negative is a positive, so I'm going to go ahead and put plus 1 and 2/10 times 1 and 4/10. So now I can go ahead and multiply. A negative times a positive is a negative, and that's going to leave me with 7 and 2/10 x. And here, combining these like terms, I'm going to get a positive 1 and 68/100. Once again, this expression is equivalent to this one, except this is a simplified version of it. So if you're wondering how I got these numbers, this was basically side work. You can do 1 and 2/10 times 1 and 4/10, and that's how I got my numbers here. Same thing here. Okay? So now, moving on. Now this problem is mine. I want you to simply just watch. Don't try to do this on your own just yet. I would read this as 1/2 times the quantity x minus 8. First thing I would do is go ahead and distribute 1/2 times x, so that's going to be 1/2 times x. And then I'm going to distribute a 1/2 times a negative 8. A positive times a negative is a negative, so I'm going to go ahead and put subtraction and put 1/2 times 8. Now watch what I do here. I'm going to go ahead and make it into a fraction to check to see if I can cross cancel. Here there's nothing to cross cancel, so I'm just going to do 1/2 times x, which is 1/2 x. Here I can make it into a fraction, and I notice I can cross cancel. 2 and 8 both have a 2 in common. 2 divided by 2 is 1. 8 divided by 2 is 4. So now I'm left with minus 1 times 4, which is 4. So here my simplified expression is 1/2 x minus 4. And again, these expressions are equivalent. but this is the simplified version. You're going to get sick and tired of me reminding you this, okay? So now we're going to go ahead and move on. I'm going to go ahead and have you try number 5 on your own. So go ahead and pause the video. So now let's go ahead and work this problem out. First things first, distribute the 3/5. Let's use a different color here. Let's distribute the 3/5 to the 5x. So we're going to do 3/5 times 5x. I'm going to go ahead and make it into a fraction right now and put it over 1. Now we're going to do 3/5 times a positive 15. So a positive times a positive is a positive. I'm going to go ahead and put 3/5 times 15, and again I'm just going to put it over 1 to make it into a fraction right away. Now we're going to see if we can cross cancel. The 5s can cross cancel. 5 divided by 5 is 1. 5 divided by 5 is 1. 3 times x is 3x divided by 1 is just 3x. Here, these can't cross cancel, but a 5 and 15 can. 5 divided by 5 is 1. 15 divided by 5 is 3. So here we're going to go ahead and say 3 times 3 is 9. Since it's positive, we're going to put plus. So once again, these two expressions are equivalent, and this is simply a simplified version of my original problem. So hopefully you got that problem right. So now for number 6, let's go ahead and practice reading this aloud. I'm going to read this as 3/4 times the quantity 8x plus 2/3. First things first is distribute the 3/4 to the 8x. I'm going to go ahead and multiply it and make 8x into a fraction right now. Now I'm going to go ahead and multiply 3/4 times a positive 2/3. Positive times a positive is a positive. I'm going to write 3/4 times 2/3. Now I'm going to see if I can cross cancel. Here 3 and 1 have nothing in common, but 4 and 8 do. I can divide by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Leaving me here with 6x. Now here I can cross cancel the 3's. 3 divided by 3 is 1. 3 divided by 3 is 1. But I can also cross cancel the 2 and the 4. So 2 divided by 2 is 1. 4 divided by 2 is 2. So this is going to leave me with plus 1/2. Here is my simplified expression. Again, it is equivalent to the original one. This is just a simplified version. Perfect. Moving on. Now, I'm gonna have you pause the video and try number 7 on your own. Okay, so now what we're gonna do is go ahead and see if you got the problem correct. I'm going to go ahead and distribute 5/8 times 8/3 x. So I'm going to show my work here. It's already a fraction, so I don't have to change it. Now I'm going to distribute 5/8 to a negative 1/7. So positive times negative is a negative, so I'm going to subtract 5/8 times a 1/7. Here I'm going to see if I can cross cancel. The 8's can definitely cross cancel, turning into 1's, leaving me with 5/3 x. Here, nothing can cross cancel, so I'm going to be left with minus 5/56. So notice here, this fraction is improper. Okay, I'm actually going to allow you from now on to leave your fractions improper. You do not have to turn it into a mixed number. I repeat. Leave your fractions improper, okay? You do not have to convert it into a mixed number because it's going to look a lot neater for your final answer. So now, moving on, I'm going to go ahead and do number 8 on my own. Simply observe and take notes with me. First things first is I'm going to recognize that I'm going to have to distribute twice. So there's nothing new about it. I'm used to distributing. It's just going to happen twice this time. So here you're going to distribute 3/5 times a 5x. So I'm going to show my work there. Notice I'm going to put 5x over 1, make it into a fraction right now. Now I'm going to do 3/5 times a positive 15. So since it's a positive times a positive, it's plus 3/5 times 15 over 1. I'm going to continue moving on and do 2/3 times 6x. Since it's a positive times a positive, I'm going to go ahead and put plus 2/3 times 6x over 1. So notice again, I'm making it into a fraction for later when I check to see if I can cross cancel. Now I'm going to do 2/3 times a -3. So positive times a negative is a negative. So I'm left with 2/3 times 3 over 1. Now I'm going to go back and check to see if I can cross cancel anything. Here the 5's are going to cross cancel, leaving me with 1. So this is going to be 3x. Here I can cross cancel the 5 and the 15. 5 divided by 5 is 1. 15 divided by 5 is 3. So 3 times 3 is 9. I'm going to be adding that. Here I can cross cancel the 3 and the 6. Dividing by 3, this becomes 1. Dividing by 3, this becomes 2. So that becomes plus 2x. Sorry, not 2x. 2 times 2 is 4, so that should be 4x. Here I can cross cancel out the 3's. They're going to turn into 1's. So notice here it is subtraction. 2 times 1 is 2. However, I'm not finished. I need to make sure I combine like terms. 3x with a positive 4x becomes 7x. And then we have a positive 9 with a negative 2. There's more positives, so I'm going to put plus. And there are 7 more positives. So my final answer is 7x plus 7. Again, it is equivalent to the very first expression. It's just a simplified version of the original. Perfect. Now, I'm going to go ahead and have you move on to the next problem. Again, I'm going to have you try it on your own, so just pause the video and see how far you can go. So now let's go over the answer. Let's get out of that. So here, first things first, I'm going to go ahead and distribute. So notice I'm going to have to distribute twice. It's doable. So let's do 1/3 times 9x. So I'm going to show my work. 1/3 times, I'm going to put 9x over 1 to make it a fraction right away. And then I'm going to do 1/3 times a negative 12. So notice that sign is making it negative. Positive times a negative is a negative, so I'm going to subtract. 1/3 times, again, 12 over 1, making that 12 into a fraction. I'm going to continue. A positive 3/4 times a positive 4x is a positive number, so I'm going to put plus. 3/4 times, you know it, 4x over 1. One more step. We're going to do a positive 3/4 times a negative 8. Positive times a negative is a negative, so I'm going to go ahead and put 3/4 or 3/4, same thing, times 8 over 1. Now I'm just going to go look over everything to see if I can cross cancel. Here I can divide by 3. 3 divided by 3 is 1. 9 divided by 3 is 3, leaving me with 3x. Here I can also divide by 3. 3 divided by 3 is 1. 12 divided by 3 is 4, leaving me with minus 4. Here the 4's cancel each other out, leaving me with 1's. So here I'm going to have plus 3x. And last but not least, I can see that a 4 and 8 have a 4 in common, so 4 divided by 4 is 1. 8 divided by 4 is 2, leaving me with minus 6. I'm not done. I need to make sure I combine like terms. 3x plus 3x is 6x. And then I have a negative 4 minus 6 is a, well, first of all, there's more negatives, and there are 10 negatives altogether. So my final answer is 6x minus 10. And again, they are, what, everyone? Equivalent. Okay, this is just a simplified version of my original problem. Okay, moving on. Now, what's going to happen is, what if you get both? What if you have decimals and fractions? What are you going to do? So here, we notice that if we convert things into decimals, things can get a little messy. However, yesterday we found out that converting our decimals to fractions might be a better way. Does it mean you cannot convert things into decimals? Absolutely not. It's definitely a possibility. You can definitely do that. But you're going to find in most cases converting the numbers to fractions is going to be a little bit better for you. So let me give you an example here. First things first, I'm going to convert all mixed numbers into improper fractions and all decimals to fractions because we want to make sure we have the same type for the terms. It's either all fractions or all decimals. So let's go ahead and do that real quick. 1 1/5 is going to become 6/5. And here, this decimal of 9/10 is going to become 9/10. So now what I can do is go ahead and distribute like I normally would. I'm going to go ahead and distribute 6/5 times 5x. So I'm going to show it like this, times 5x over 1. Then I'm going to distribute 6/5 times a positive 8. So a positive times a positive is a positive, so I'm going to put 6/5 times 8 over 1. I'm going to continue on this pattern. Positive 9/10 times a 6x is a positive, so it's going to be plus. I'm going to do 9/10 times 6x over 1. Now I'm going to multiply 9/10 times a negative 3. So since it's a positive times a negative, it's going to be subtraction. 9/10 times 3 over 1. Now we're going to just look over everything to make sure we can cross cancel if possible. Here the 5's can cross cancel, leaving me with 6x. Here you can't cross cancel anything, so you're just going to leave it as a fraction and multiply it across. 48 over 5. Now here we're going to add. Here, can you cross cancel? Yes, divide by 2, turning this into a 5, turning this into a 3. So you're left with 27x, because 9 times 3 times x is that, over 5 times 1, which is 5. Last but not least, can you cross cancel? Unfortunately, no, so you're left with minus 27/10. So now you're going to have to combine like terms. Unfortunately, it's not nice and neat, but it's doable. So let's go ahead and combine a 6x with a positive 27x over 5. So I'm going to go ahead and do that off in my side work. We're going to put 6 over 1 plus 27 over 5. My lowest common denominator is going to be a 5, so I'm going to mark that as so. My first fraction is going to have to change by 5/5 to make that denominator a 5, leaving me with 30/5 plus, since its denominator is already 5, the 27 remains the same, and you're left with 57/5. And again, notice I told you can leave your answers improper, so this is good. You don't have to go any further than that. So now, actually let me change this color into red so that I can color coordinate. 57/5 x. Perfect. Now I'm going to go ahead and combine a positive 48/5 with a negative 27/10. So I'm going to show my work. 48/5 minus 27/10, where 10 is my lowest common denominator. I'm going to have to change this numerator right here by 2. So, sorry, the denominator by 2, so I'm going to change the numerator by 2. 2 times 48 is 96 minus, just bringing that down, 10, the denominator is already 10, so I'm going to keep the 27. 96 minus 27 is 69/10. So I'm going to go ahead and write, since it's positive, I'm going to write plus 69/10. So notice, keeping your answers as improper fractions is going to make it look a lot neater. So from now on, you are going to be asked to leave your answers improper. It's gonna take you a while. Some of you might want to put it as mixed numbers. I'll be lenient for the first few days, but eventually I expect you to write your answers as improper fractions. Okay, so now moving on to our very last example. Now we have, again, we are going to have to distribute more than once, but we know how to handle this. First things first, I'm going to ask that you convert all your decimals to fractions and all your mixed numbers into improper fractions. So first of all, I'm going to show you off in my side work. So I'm just going to split the screen real quick. 1 and 5/10. I'm going to write that. 1 and 5/10. I can reduce this fraction by 5 and I would end up with 1 and 1/2. But we don't want a mixed number. We're going to turn it into an improper fraction, and this is equivalent to 3 halves. So let's change this to 3 halves. Okay, so here 1 and 3/15, I'm going to change this to an improper fraction. 5 times 1 is 5 plus 3 is 8, so this is going to become 8/5. So now let's go ahead and go about our regular business. We're going to do 4 times 3 halves. Since they're positive, I'm just going to leave them positive. 4 over 1 times 3 over 2. Now let's do 4 times a negative 3/5. Positive times negative is a negative, so I'm going to subtract. Notice I'm putting 4 over 1 to make it a fraction and multiplying it by 3/5. Moving on to the next set of distributive property, I'm going to do 8/5 times 2x. Since they're both positive, I'm going to put plus 8/5 times 2x over 1. And again, I'm just putting it over 1 to make it into a fraction. Now we're going to do 8/5 times a positive 5. A positive times a positive is a positive, so I'm going to put plus 8/5 times 5 over 1. So now what I'm going to do is check to see if I can cross cancel. The 4 and the 2 have a 2 in common. 4 divided by 2 is 2. 2 divided by 2 is 1, leaving me with 2 times 3, which is 6. Divided by 1 is still 6. Ooh, I made a big mistake. I left off a very important thing. I forgot the variable, so please make sure you include that. I made a big boo-boo there. So it's going to be 6x, not just 6. Perfect. Here, can I cross cancel? Unfortunately, no, so I'm going to go ahead and put minus 12 over 5. Here, again, I'm going to check to see if I can cross cancel. I can't. So I'm going to put plus 16x over 5. Here, can I cross cancel? Yes, the 5's cross cancel, leaving me with plus 8. Now what I must do is combine like terms. I'm going to combine a 6x with a positive 16x over 5. I'm going to go ahead and erase this to make myself some space. So let's go ahead and show my work. We have 6 over 1 plus 16 over 5, where 5 is our lowest common denominator. Here, you're going to have to multiply the denominator by 5. So the numerator is multiplied by 5, leaving me with 30. Here, since the denominator is already a 5, the numerator is going to stay the same. We're going to add, leaving us with 46/5. It's already reduced, so I'm going to go ahead and leave it as so. We're going to put 46/5 x. Now moving on to the to the constant, I'm going to combine a negative 12/5 with a positive 8. I'm going to show my work. Negative 12/5 plus 8 over 1, where 5 is our lowest common denominator. So since 5 is already a 5, the numerator gets to stay the same. Here, the denominator is going to have to change by 5 to make it a 5, so the numerator is going to have to change by 5 as well, leaving me with 40. We're going to still add a negative 12 plus 40. Well, first of all, there are more negatives or positives. Hopefully your answer is positive. And how many more positives are there? Well, there are, let's see, 18 more positives. So it's going to be 18/5. Is this reduced? Yes. I'm going to go ahead and leave it improper. And since it is positive, I'm going to write plus 18/5. And that is my final answer. Again, they are equivalent. This is just a simplified version of the original problem. And that's it. Okay. Thank you again for tuning in. If you have any further questions, feel free to email me on my website at any time. Thank you. Bye.